Okay, so I find it helps with these ones to draw a picture if you're a bit unsure. So we've got A and B, and we're putting a point, let's say P, internally to start with, so in between A and B, so that it breaks it up into the ratio 1 to 2. So if I had A here and B here, you can imagine 1 to 2 would put P there. So this distance here is 1 and this distance here is 2. So yeah, okay, and A is 2 minus 1 minus 2. P, we don't know what that is yet, but we've got to find that out. And B is 5 minus 8 here. So if I look at it, I couldn't use what they gave me, but if I look at the picture, it makes it really easy. You can see, and I only want to use P once because it's got the X, Y, Z. And be careful here a little bit. So I could say, look, AP, so that vector there, let's say AP, that vector, is what scalar of this vector here? It is 1 out of 3. So it's a third of that vector AB. So you can see I've only used P once, which is what I want. I don't want too many X and Y's if possible. So A to P, so I take P first, which is X, and I subtract 2. Oops, and I've done it again. Get rid of that. And here we go. So I subtract 2. There we go. So that's AP, and then I take the Y and I subtract -1, and I take the Z and I subtract -2. So that has to equal a third of, alright, I take the B and I subtract 2, I take 5 and I subtract -1, and minus 8 again, subtracting -2. So I've got that. So if we want to take each one separately now, X minus 2 is a third of 5 minus 2. So X minus 2, for example, is a third of 5 minus 2 is just 3. So we get a 1 there, so X equals 3. I'll just circle that so I know I've done it. So taking the Y's, we've got Y plus 1 is equal to a third of, and this is 5 plus 1, which is 6, so that's going to be a 2. So Y equals, when I subtract 1, Y equals 1. Did I get that right? Hopefully. Alright, so I feel like I may have got that wrong somewhere, but you can check. Alright, so Z plus 2 now, I'll just put it over here. Z plus 2 is a third of minus 8 plus 2 is minus 6, so this is a minus 2. And if I subtract another 2, I get 4. So from that, we could say, well, our OP, or our position vector of P, is, I'll put it in the same format. So X was 3, Y was 1, and Z was minus 4. Alright, so we can just put that in, that's for that one internally. So for externally, it's going to look a little different. And so externally means the point P lies outside that interval AB. So if you think about it, it says in the ratio 1 to 2. So the ratio, or the distance to A, is closer than its distance to B. So again, if I draw this, if I put A and B here, you can see that P has to be here because it's closer to, so this distance, A to P, is 1, whereas B to P is a distance of 2. So it's external, it's outside, and it's still in breaking up the interval in the ratio 1 to 2. So it's definitely going to be closer to A. So again, in this case, I don't want to use P twice if I can help it. So what we like to do is, for example, I might go this way this time and say BA, this vector, is a certain fraction of this vector. So let's have a look at what I would say then. So I'd say BA vector is, did I get the ratio wrong? Oh, yeah, so if that's going to be a 2 there, and that's a 1 there, then this must be 1, right? So it's 1 out of 2, so it's going to be a half of the vector PB. So it's nice when you draw a picture, it just seems a bit easier. Okay, so BA, we had that from before we had AB, so I just take the negative of that, but I'll write it down anyway because I've rubbed it out. Alright, so I'll have 2 minus 5, 2 minus 5 minus 1 minus 5, and minus 2 minus 8. That's my BA, and that's going to equal half of. Looking at BP, so P being X, and B being 5Y, 5Z, and that's plus 8. Alright, I might take each one separately. So taking the X's first, 2 minus 5 is minus 3, and I'm actually going to double everything instead. So minus 3, double it, gives me minus 6. I hope you're okay with that. That's X minus 5. That's an equals. So if I add 5 to both sides, I get X is equal to negative 1. Alright, taking this 1 minus 5 is minus 6, double it is minus 12. And on the other side, I've got y minus 5. Alright, so if I add 5 to that one, do I do that? Yes, I think that is correct. So add 5 and I get minus 7. I'm looking at this thinking, have I done something wrong? But you can check my working and let me know. So this one, looking at Z, 8 minus 2 would be 6, but double that and that's a 12 as well. And across here, that's Z plus 8. So if I subtract 8 from both sides, I get a Z equals 4. So again, this time my OP vector would be in the same format. They've got it. Minus 1 is my X, minus 7 is my Y, and 4 is my Z.